Have you ever wondered if time travel is possible, or if wormholes really exist? Welcome, fellow explorers of the unknown, as we embark on an audacious journey, a voyage not restricted by the boundaries of our three-dimensional world. Today, we delve into the enigmatic realms of time travel and wormholes, concepts that tantalize our imaginations and challenge our understanding of reality. Picture this. We exist in a universe of 4 dimensions, 3 of space and 1 of time. We're all familiar with the 3 spatial dimensions: length, width, and height. But there's a 4th player in this cosmic game, an elusive yet essential dimension: time. Time is not merely a measure of events, but a dimension as real as the space we occupy, intertwined with it to form the fabric of our universe known as spacetime. But what if this fabric could be manipulated, bent, folded, or even twisted? Enter wormholes, the theoretical tunnels in spacetime. Imagine you're trying to reach a point on the opposite side of a piece of paper. Instead of traversing the entire surface, you could fold the paper and create a shortcut. This is the idea behind wormholes, a shortcut through the fabric of spacetime itself. They are like cosmic backdoors, potentially connecting distant points in space, different universes, or even different points in time. The concept of wormholes and time travel has long been a staple of science fiction, from H.G. Wells' The Time Machine to the interstellar voyages of Star Trek. But they are more than mere flights of fancy. They are predicted by the equations of general relativity, the very same equations that accurately describe the motion of planets and the expansion of the universe. If you have ever dreamed of journeying to the stars or back in time, you are not alone. But what does science have to say about these fascinating concepts? Stay with us as we continue our journey, exploring the boundary where imagination meets science, where the impossible may just be possible. Time travel, a concept that has captured our imaginations for centuries. But is it just a plot device for science fiction stories, or could it be a scientific reality? Let's delve into this, shall we? Time travel, as we know it, often features prominently in our favorite science fiction tales. From H.G. Wells' groundbreaking novel, The Time Machine, to the blockbuster movie franchise Back to the Future, we've seen countless renditions of what it might be like to hop between different eras at will. But is there any scientific basis to these captivating narratives? Enter Albert Einstein, the renowned physicist who shook the world with his theory of relativity. His theory fundamentally altered our understanding of physics and introduced the fascinating concept of time dilation. But what exactly is time dilation? In simple terms, time dilation describes how time can appear to move slower or faster, depending on how fast you're moving or the gravitational force you're experiencing. This is a direct result of Einstein's theory, which states that space and time are interwoven into a single continuum known as spacetime. Picture spacetime as a trampoline. If you place a heavy object, like a bowling ball, in the middle, it will create a dip, distorting the trampoline surface. This is similar to how a massive object, like a planet, distorts spacetime. Now, if we apply this concept to time travel, we can start to see some interesting possibilities. Imagine a spaceship traveling near the speed of light, away from Earth, and then returning. According to the theory of relativity, the astronauts on the spaceship would age slower compared to the people on Earth. So, when they return, they would effectively have traveled into Earth's future. However, it's important to note that this is still largely theoretical. We have yet to develop the technology to test these theories in a meaningful way. So, while time travel remains largely in the realm of fiction, the theories of Einstein suggest it might not be entirely impossible. Wormholes, are they just a sci-fi trope, or could they be real? Let's delve into this fascinating concept, shall we? Wormholes. They've been a staple of science fiction for decades, appearing in everything from interstellar epics to comic book adventures. They're often depicted as gateways to other realities, shortcuts through the cosmos, or even time machines. These imaginative interpretations captivate us, stirring up dreams of distant galaxies and an unbound future. But what does science have to say about them? Well, theoretically, wormholes are possible. They are solutions to the equations of Einstein's general theory of relativity, which describes the fabric of space and time. Imagine spacetime as a 2-dimensional sheet. Now, if you were to fold this sheet so that 2 points touch, you'd create a shortcut, a tunnel if you will. That's what we call a wormhole. In essence, wormholes are bridges through spacetime. They connect 2 distant points in the universe, making the journey between them significantly shorter than it would be if one were to travel the conventional way. Theoretically, if one could construct a wormhole and keep it stable, it would allow for faster-than-light travel. However, there's a catch. To keep a wormhole open, one needs something known as exotic matter. This is a type of matter that has negative energy density, which is not something we currently have or even know how to create. Also, there's the problem of size and stability. Natural wormholes, if they exist, are predicted to be microscopic and extremely unstable. They would collapse instantly, making travel through them impossible with our current understanding of physics. Despite these challenges, the concept of wormholes continues to spark our curiosity. They embody the limitless potential of human ingenuity and the mysteries of the cosmos waiting to be unraveled. Wormholes may still be a theoretical concept, but their potential implications for space travel and exploration are truly mind-boggling. So where does this leave us on the reality of time travel and wormholes? As we've journeyed through time and space together, we've seen that time travel and wormholes are more than mere fodder for science fiction. These concepts, once the realm of wild imagination, have found a home in the serious discourse of theoretical physics. The current state of scientific research, however, is still grappling with the monumental challenges these theories pose. Time travel, for instance, raises paradoxes that tangle our understanding of causality and sequence. Wormholes, on the other hand, require conditions so extreme and energy so immense that they seem beyond our grasp. Yet even with these limitations, the allure of these ideas persists. They push us to question, to explore, to dream. They expand the canvas of our scientific and creative endeavors. While we may not be packing our bags for a trip through time or a journey through a wormhole just yet, these concepts continue to intrigue us, inspire our stories, and push the boundaries of our understanding of the universe.